Okay, so today we are going to talk about functions. The way you have never seen before. Understand exactly what functions are and how they work in C++. And for that, those things I think didn't work, right? The lights. Let me see if it. Maybe I have access here. Give me a second. Let me check. Because this is too bright. No. How do we turn the things off and on in here? It's always on. I don't know. Hopefully you can see something in here. Kind of. Anyways. Before we begin, just letting you know that we're going to go back to OOP345, do a quick review of what we've done before, and then see what problems that we have in OOP345 and try to fix it with new things we're going to learn about functions in C++. Remember about foolproof entry we did in C? We wrote a function that received, say, an integer, and we wanted to see if it's good or not. I can't enforce anything at home, but please, if you're here, put your cell phones and stuff away and pay attention to the class. It's good for you, trust me. All right. So in OOP345, to actually have some kind of a foolproof entry, what we did, we created, say, a function called getInt. So I want to have a getInt function that receives an integer. And we wrote getInt, simple and straightforward. And hopefully we would receive a number, and at the end we would return that number if the student went through, if the user went through proper stages to entering a proper integer. So what we did over there, we said, okay, so the standard way of doing it is to check to see if we are done with our validation, and then we repeatedly ask the user to enter something, and we continue doing that while we are not done with our validation. And that's essentially any type of user interface. Any type of user interface, essentially it's an endless loop trying to ask the user something, and user passes through validation and does whatever it's supposed to be done. So ideally, we're going to receive an integer over here from the user, and then we're going to check to see if Cin actually failed in receiving that thing. If it failed, we'll do something. If it didn't, we do something else. So if it failed, first we apologize from Cin that the user enters something it couldn't get. So essentially clear the thing. So Cin talks back to us. And then after that, we're going to say, OK, you have an invalid integer here. Please try again. And I'll go to new line. And I ask for it. Obviously, if they enter something garbage, at the end, no matter what they do, they either have garbage after whatever they enter, or they have just one \n. So no matter what happens when somebody's doing foolproof entry, when they enter the number, they enter some value and hit the enter. If the number is red, the enter is in buffer. If it's number and some garbage, it's garbage and enter. So it's safe at the end to flush the keyboard saying, hey, ignore no matter how many numbers of characters coming until \n. So no matter what, I'm going to either wipe out only one new line or lots of garbage in new line. So so in else, what happens? When we are in else in here, we know that Cin successfully read an integer. But that's not enough, because they may enter an integer and some garbage after. I want only an integer. So I'm going to take a peek and see what's coming next. If what they enter, what is about to come in right after is not equal to, \n, that means they had some garbage coming in afterwards. It's not only an integer. There are other stuff coming in. So if that's the case, then I'm going to say, hey, only an integer, please. Please try again. So now, at this else part, user definitely entered an integer and an integer only. So in here, I'm good to go. Am I? If I ask for someone's age and they put 5,000, does that make sense? No. So down to here, an integer is valid, but what is the validity? I don't know. Usually what we do for these type of scenarios is that we have some kind of validation function somewhere that tells us if an adult is correct. So if it's between 18 and 65, it's an adult. Otherwise, either a child or a senior. Or if I say valid number of students between 10 to 35 to form a class. If it's less than 10, the class will not be there. If it's more than 35, it's too many. So we have validations like this. Now we can use those type of validations to actually check the validation. So we can actually say, hey, if it is an adult, done is true, I'm done, everything's good. The integer is valid, the number is within acceptable range, so let's continue. Done is true, it ignores the single new line that it hasn't comes out. If not, it's going to say no children or seniors and go back. So this is a foolproof entry, perfectly working. There is one problem with this one. The problem is that if I want now check the number of students, I have to change line number 27 and call the other function for validation and recompile the whole thing. Think about it for a second. This validation works perfectly. So what is the solution? The OOP345 and IPC144 solution is that write different get ints, right? Get age, and call the get int and apply the thing after. But it's going to bloat our code. For every single integer that I want to get, I have to have another function written. That's stupid. I don't want that. So what's the solution? Bear with me. So first let me compile this, make sure it works. It would have been interesting if I actually called the function. I didn't call the function. So let's do it again. So enter your age. I put some garbage. It's going to tell me invalid integer. We'll fix that. Okay. And if I enter over here 2, it's going to say no children or seniors. If I put 77, no children or seniors. If I put over here 24 is the number of years I lived. Still, it's going to say, hey, only an integer. Don't give me that thing afterwards. I just need an integer. Now, if I actually put 24, it's going to say age 24. We're good. Are we okay with this? So this is good. This is a foolproof thing that we have. So it looks okay to me. Integer. Somebody needs to teach me how to type integer. Hopefully it's good. All right. Anyways, save. So this is essentially a 244 foolproof integer entry. Please keep that in mind while I continue with the lecture. Pay attention to what I'm going to put over here and see if you can answer the question. So you see those two functions? What's common between the two functions? Do you know what's common between those two functions? They have same parameters. So they have same, okay, same parameters, since you answered. So it's got to be your turn. What does it mean they have same parameters? What do we call that thing when function have same parameters? What do we call that in C?
Overload.
Nope. They're not overload at all. Nothing to do with each other. They're two separate functions. There is something common between the two. They have same parameters, which in C language means they have the same signature. Okay, but please wait your turn. Okay, if you keep answering, other people will not. So please wait your turn. They have the same signature. Are we okay with this? Are we okay? They have the same signature, which means they return void and receive two integers, right? Okay. Now, past that, your turn, my friend. Do you remember when I was talking about arrays? What did I tell about arrays? I said arrays are essentially piece of memory with, remember what it was? What is an array? If I write integer A5, what does it mean? It means I have 5 integers and, can you complete this sentence? Pass. Can you complete this sentence? Bad people you are. Pass. Okay. Anybody at home? An array is a piece of memory with what? Anyone at home? When I have an array, you essentially create something like this. So if I write over here integer A5, I'm going to repeat what I said before that you did not study it. So essentially I would say an array is a piece of memory with what? Do you remember now? With a pointer pointing to it. So essentially, A in here holds the address of those 5 integers. Are we okay with this? So if I print A, it's going to show a piece of memory to me. We're good with that? So let's just remind you of this, because this is important. This is extremely important, as a matter of fact. So what I'm saying is, where's my cheat sheet? what I'm saying is I can do this. And when I run this program, it is going to show me where those 5 integers are in memory, which it happens to be this address. Are we okay with this? Okay, I have news for you. You see the functions written up there? They're exactly like arrays. An array's name holds the address of data it's pointing to it, where a function name is a pointer pointing to the address of logic in memory. Every program you're writing is loaded into the memory, right? And that's how it gets executed. That's the definition of an executable. It's some piece of code that goes in memory and CPU executes the line by line. When we put an array, A5, we have 5 integers, and A holds the address of the beginning. When you have a function called sum and you call that sum, so when I actually do this in here, when I say sum 10 and 20, when I do this, these parentheses in front of the name of the function means jump to that address and pass the arguments. Essentially, parentheses means call. Essentially tells to C++, hey, call the code written at these address. So if I run this, obviously, it's going to show the address of sum and prod in memory. There we go. That's the address of sum in memory. That's the address of prod in memory. And this is when the sum is called. So essentially jumps to the first address at the top, executes the lines until it finishes and comes back in. That's what the compiler does. That's what the C language does. Are we okay with this? Now, we know that I can do something like this over here. So if I have over here if I have something like this in that A, I can say integer pointer P equals to A. Therefore, P is pointing where A is pointing, right? And because of that fact, if I say cout P2, essentially what happens is that it's going to show the second element of A because P is pointing to that location. Are we okay with this? So P and A are both pointing to these 5 integers. Therefore, P2 is the same as A2. Are we okay with this? So I can access P using a pointer. That's how you did all the functions, right? When you write a function over here, you can actually write a function over here like this. You can write int foo and say integer pointer P, and you can do the exact same thing you have done over here. And you can say foo A. This is essentially the exact same thing. I am passing the address of the beginning of the array into P. Now P is pointing to those 5 integers. Therefore, P2 is 300. Are we okay? Well, build errors. Nice. Seriously? No. Oh, because I'm running something here? Oh, yeah. No. What did I do wrong? One more time. No. What is it going on? Oh, must return a value. Sorry, void. My apologies. There we go. Are you okay with this? Now forget about arrays. I want to concentrate on functions. Think about it for a second. Sum is the address of where the logic of sum begins. Prod is the address of where prod begins in memory. If I could create a pointer of the type of any function that receives two integers and a void, I can use that pointer to call these things. So how do I create that pointer? So first of all, so if I want to create it, so I'm going to write over here func name. So this is the signature of those things like int and int, right? This, everybody agrees that this has the same signature at line 12 of any of those two, right? Now, if I want to change this to a variable instead of a prototype, what do I need to do? When I had an integer, and if I wanted to make it a pointer, you put an asterisk beside it, right? So I'm going to do the same thing. I'm going to say pointer, but there's a problem now. This is not a pointer of a function that receives two integers and returns void. This is actually a prototype for a function that receives two integers and returns a void pointer. So this asterisk stuck to this type by definition. I have to unglue the two and bring the asterisk to the name to say this is a pointer, not a signature. For that, you have to enforce it with parentheses. If I can type it. Now, func name over here is not supposed to be func name anymore. I'm going to actually change that to func ptr. Now, func ptr is a pointer who's capable of holding the address of any function that receives two integers and returns nothing. Anything. Like I can write over here something like this. I can say void repeat integer num and int value. And in here I can say for integer I set to 0, I less than num, and I plus plus, I can say if I is equal to 0, not equal to 0, or if I, then I'm going to say if I is not equal to 0, I'm going to say over here cout a comma, and I can say cout val. Right? Is that correct? So if it's 0, it's not going to print it. If it's not 0, it will print it. So hopefully it's going to be fine. Now, all these three have same signatures, completely different purpose. But the signature of the three are the same, which means instead of saying sum, in here I can say func ptr is set to sum because they have same signature. So now func pointer is pointing where sum is pointing. Therefore, instead of sum, I can say func ptr. And when I run this now, it works the exact same thing. It's as if I'm calling sum. So it's going to actually print 30 over there. Not only that, I can do this now. Now this is prod. Now this is repeat. When I run the program, now through a function call that you see over there, the function call that you see over there, the first func ptr prints the sum. The second func ptr prints the product. The third func ptr repeats 20, 10 times. I use the exact same function call for 3 different functions. Does that make sense? Are we okay with this? Yes.
Why do you do that? Like,
I'll come back to it in a second.
oh,
Why? Because I just want to bother you.
no,
No. But you understood what happened over here?
yes.
In 2 seconds, I'm going to answer your question. 2 seconds. So let's go back to the problem we had in OOP345. So this one is C func PTR intro. Now let's go back to what we had before. The problem that we had, what the heck? No, not that one, NBB. The problem that we had before. So we created this foolproof thing. That's actually the best question that a prof can get. Like when you understand what to say and say why we are doing it, I'm a happy guy. Okay, so look at this get in thing. You see that? The whole purpose of reusing it hangs on the validation function here, right? I could make my getInt behave differently if I could change this validation function on demand. So instead of writing it like this, I'm going to say, hey, pass to my getInt a function, any function that receives a Boolean, and let's call it isValid, and receives an integer. That's essentially a pointer to a function, right? Which happens to be the signature of any validation function that you have for an integer. They receive an integer, they do a validation, they return a Boolean, right? Correct? Now, what I need to do over here is to bring this one, copy, and put it over here. Instead of saying is adult, I'm going to say is valid. And I'm going to make this a generalized message saying invalid value. Okay? Now, in here, I'm going to say enter your age. And in here, I'm going to say enter the number students, student number of students in class, number of students in class. Now, all I need to do is to pass the address of isAdult to this one and pass the address of valid number of students to this one. Done. Now my getInt behaves differently. When it's called at line 13, isValid becomes isAdult. When it's called at line 16, isValid becomes valid number of students. Therefore, validation change. Now I can reuse my getInt for anything as long as they provide the validation function for me. Take a look. So when I run this, build error. What is the build error? Let's see. Age redefinition. Oh, sorry. Number of students. Number of students. Okay, let's recompile. So when I run this, take a look. It comes over here. Now, I'm not calling isAdult function. I'm only putting its name over here. Therefore, the address of where that logic begins in memory will be passed to isValid. IsValid will point where isAdult is. So when it goes to that function call, you will see that isValid is actually isAdult. You see this? It's very small if you can see that. Yes?
I have a question.
Yes.
But there's like a C++ way of doing this, right? Like std function or something?
50 different ways. 50 ways to lose your lover? I'll show you. This is literally C. It has nothing to do with C++. We'll come to C++. First this, and then we're gonna go in like two different ways to do the exact same thing, okay? So now we'll come in here, and it comes in here, it does that CIN thingy. Now if I put over here 24 and I hit enter, obviously it passes all those things, but when it comes to is valid, it actually, where does it go? It goes to is adult, because is valid is pointing to is adult, and that's the validation. And therefore it's done, and it comes back and prints whatever it's supposed to. But now it shows the entity, so let's put it at the left, and so we can see this at right. Okay, so it says age 24. Now it's gonna tell me enter number of students. It goes to get int. Is valid is now number of valid students. Okay, then it comes in here. Now it receives it. I'm gonna put over here 30. Hit enter. Now it comes in. Everything's good. Now it's gonna call is valid, but where it goes is actually valid number of students because it's pointing to that. So essentially, I change the logic based on what I want to do. You can pass logic to functions. You good with that? All right. So this is the C way. C way of passing logic to another two functions, which is essentially pointer to functions. Now, the problem with this essentially is that this is generalized, right? It doesn't give you a customized error message for what is coming in. But for that, we can simply demand the user of my getInt to give me a different function. So I can make my function better by doing something like this. I can say, okay, my getInt demands that you give me a function that not only validates an integer, but based on that validation, it's going to set a string for me. And I'm going to show that string instead of an error message. So it's even become more customized. And therefore, the person who's actually using that, using my int, will create is adult in a way that it checks to see if it's not right. It sets the error message to something, and result is false. And this is a better way of doing it. So result becomes that if result is incorrect. So essentially, my validation actually sets the error message too, not only the validation. Therefore, now my function over here works in a better way. So it is essentially the same, but in here I have to change the prototype. So as you see, the function calls remain the same. It still says is adult and valid number of students, but how the function works is different. So the pointers that it's receiving requires a function that receives an integer and a string reference, and that's how it's going to act. Okay? It works the same way. Please run it at home and see what it is. Oops. So in here, I'm going to say the E, func ptr in use. Do you want me to walk through this? We understand how it works, hopefully, right? Anybody wants me to walk through this? Okay, so now that we have this, let's actually look at something else that we can do. Another thing that you can do with function pointers is that you can serialize different actions in arrays. So you can actually have different types of functions with the same signature put in an array. Another cool thing you can do. I can create an array of 4 function pointers that receive 2 integers. Then first set the first element to add, second to sub, third one to mul, and the other one to divide, and then go through the loop and call them one by one. Therefore, 4 different functions are called in different parts. So, like for example, if you have a menu that decides what action is supposed to be called, and you want to call a specific action without a switch statement, you can literally put all the actions in an array, and based on user's choice, you can call different index. And it works the same way. So you don't have a switch anymore. You have a much faster way of calling different functions. So it works the same way. I'm just going to compile and run to show you that it really calls 4 different functions in a loop with absolutely no problem. Are we okay with this? So as you see, the first one is calling, so it's 10 plus 2, then 10 minus 2, then multiply, and the division. So 4 different calls. Are we good? All right. So today we're going to go almost to the end of function pointers, so we're going to finish it. And the next day I'm going to demonstrate many different ways. Functions in C, in C++. So we learned the syntax and a little bit of use of it. And then the next day you're coming for the lab. We're going to do I'm going to give you a comprehensive example of really how it's supposed to be used. All different types of functions that we have in C++. And then talk about exception handling. So that's what we're going to do in the next day you're coming in during the lab. And next week, week's number 6. This is week 5, right? 6, you have a quiz. 7, you have your midterm. Remember that.
When is the assignment?
Pardon me?
Assignment?
-2. -2. You write the submit command and write a -2 at the end. It tells you exactly when the due date is. Every single thing does that. If you need extension for your assignments, please ask and go through the.
Is there an assignment to do right now?
Pardon me?
Is there an assignment right now?
I wrote the command not to answer you that. So you go to Matrix and you do a -2 and it tells you. And you have to watch the assignments page. So the question that you're asking is just going to mention to you like this. So where is it? Seneca 345. So OOP345, assignments. So assignment 2 is released. Assignment 1 was released 2 weeks ago. Now assignment 2 is released 3 days ago. You need to watch this. So what you need to do, you need to actually, you see this over here? Oh no, where is it? There's a watch in here. Where did they move the watch? Oh, this because it's not, this is the one. Yeah. So in here, you see, you click on watch, and what happens is that any change to the repository, it sends you a message. So you know. And when is it due? You go on PuTTY. If I still have it here and it didn't remove it. Yes, it's here. So you go to PuTTY. And You go tilde farda.solimanlu / submit. Anybody knows what is a submission? 345, I think ASGN1 and then -2. There you go. So it shows you the due date for anything that you have. So, and if it's past due and you've missed it, ask for an extension. I'll give it to you. No problem. Assignments in, we treat you as adult in OOP345. So everything's there. You just look at the assignment, you do the assignment, and essentially practices whatever I teach in class. If you need extension, you let me know. And how to ask him for an extension? Check the team messages. It tells you exactly how. Okay, thank you. Okay, so that's that. Now, going back to what we were talking about. Mention one thing, and then we're gonna do a quick count of who's here, and then we go for a break for 5-10 minutes and come back, okay, or 5 minutes or something, if you want. If not, we can continue. Okay, so let's take a look at this. Let's say I have a class, foo, okay? I have over here a number over here, and that number is set to, I don't know, 1. Okay? No problem down to this point. And then in here, we know that we can overload any operator in C language, C++, most of them. Very few ones you cannot. So say I want to show the value of that number, I can say, I don't know, if anybody casts this to an integer, return the number. So if anybody creates an instance of this, they can go cout int f, it means cast f to foo, and then they return it. And they run the program, you know what happens, it just prints 1 over there. Yes?
When does assignment 1 due?
Didn't I just mention it 2 seconds ago? -2. So you go to, for each person it's different, depending if you have accommodation, if you ask for an extension.
I didn't know there was an assignment at all.
It's always in the assignments page, okay? So it was probably due a week ago or something. Yeah, you need to check the repository at all times, okay? You need to do that. By now, you need to know that. Anyways, so what I wanted to say, let's not get distracted from this. Assignment, schmassignment. Let's pay attention to what we are doing now, okay? Please. Okay, so now when we are actually having an operator over here overloaded, the operator over here is casting, and we can do anything we want to do with it. Be okay with this? When you look at a function call, what indicates what is being called? So you have over here simply a pointer. To tell to the compiler this pointer is a function to be called, you put parentheses in front of it, right? That is actually an operator, as you overload the index operator with square brackets. You can do that, right? You can do the exact same thing over here. So I can actually come over here and do something like operator say int operator function call, and I write over here int num1 and num2. So what I'm essentially doing is saying that, hey, if the function call operator is called with this thing, return num1 plus num2. So what does this thing do? It means when I create an instance of foo that is f, as I applied the cast operator over here, I can apply the call operator. I can literally say cout call operator returns, and in here I can say f 10 and 20. So I can actually treat the object like a function. See, I'm saying f over here, that is an instance of foo. When the operator is called, when the call operator is called, go to this operator overload and pass 10 to this and 30 to that. So essentially what I'm doing here is that when the function is called, when the operator is created, when it comes to this operator overload, it says f is an instance of foo. Foo has overloaded the call operator with 2 integers, so I'll go to that one. And it returns and brings it back, and it becomes 40. As simple as that, right? It's simply an operator overload. I named it bad. I shouldn't have called it foo. It's better to call this one add, and say over here I can do something like NO++ and make this one 0. So it's exactly the same thing. And instead of operator in here, that's fine too. So now in here I'm going to say add. And I'm going to call this one add because it just makes sense. Now in here I can go add. And when I cast it, it's going to tell me how many times the add function was called. Because it's not just a function anymore, it's a class who has an operator overload for a function call. Now, if I call this function several times, I can say cout add was called int add times. Okay? And you call that, because it's a function, it's a class, it does what the class do. It's just a method is called over there, and it's called 6 times. So you can see that. So as you say, the class is impersonating itself like a function. These type of classes are called functors. Functors or function objects. So any class that overloads the call operator in any way, it's a functor. You okay with this? So when you think about it, I don't need to pass pointer to a function anymore. All I need to do is to create a functor and pass the function, pass the object to a class, to another function. This is C++'s way to answer pointer to functions. So take that extremely structured way, which essentially, so think about it, pointer to function is an absolute disaster in object orientation. In object orientation, you're looking about privacy and what method belongs to what class and everything. And pointer to function goes to the guts of your executable, extracts the address of some code, redirects the CPU with no limitation and no privacy, and says execute that function. It's awful. C++ says don't do that. Instead of doing that, create a class, overload a function in it, a function call in it, and pass the object. Now, we're going to show you examples on how it changes it properly depending on what it is. We already know it. We'll come to it too. But I'm just showing you that this is a functor. Just for now, keep that in mind. So this is essentially functor's functor introduction. We're going to go through details the next day that you're coming in. And the next thing we need to look at is that going back to function pointers, is that you should remember that function pointers are literally signature of functions. So anything you have done with templates and function templates, you can do them with function pointers with absolutely no difference. So essentially, if, for example, the sort in here is a templated sort that sorts any object using a comparison object between the two elements. You remember bubble sort. Bubble sort goes through a nested for loop, compares neighboring elements. If they are not in order, it switches those places. So all I'm doing over here is saying that, hey, compare the two using a function pointer. And I'm making that templated. So you can simply have a template of any function and pass the pointer to that one. It's a direct result of pointer to function. So essentially I'm saying if I want to do ascending, you have to compare type T and type B with a greater than. So any object that implements greater than operator, you can use this template for it to sort them. So pointer to functions with templates is exactly like regular functions, no difference. Just apply it as it is, and it's a direct result of it. And when you are calling the function, you simply say, hey, sort A for 7 elements using the ascending function of type int. So you're essentially telling which function pointer is supposed to get created for this. And it just creates and pass the pointer to it. So pointer to template to pointer to functions is this exact same thing as regular functions with absolutely no difference. Please walk through this again at home to see what they are. So this is EFGH. Function pointer templates. Okay, now let's quickly go through all the fundamentals of functions, but before that, let's take a break. So what I'm going to do for all the people at home, please do me a favor and
Professor,
yes.
already was a first assignment?
Pardon me?
Already was first assignment?
I don't understand that. Already was first.
Sorry, I mean like its first assignment already was posted like a few weeks ago.
Yes.
Then I guess we need extension because
Yeah, please
didn't
go
notice
through,
it.
yeah, please, if you missed it, please go to your team. It's OOP345 office, and over there you'll see extension request, how to do it. If you need an extension for anything, please follow these instructions. I'll give you an extension, there's no problem with it.
Okay. I also were assignments posted. I mean like how to don't miss it next time, like
I think I just mentioned it, but I'm going to mention it again. Essentially what you do, if you go to your subject page, so course says OOP345NBB you are, right?
mm-hmm.
So you click on assignments and assignment 1 or 2. It's right there, okay?
Mm-hmm.
All right, or go to course information then you click the GitHub organization, then it takes you to the organization, then you go to 345, and then you go to assignments. And the other ones are exercises, so things that you want to do practice with, different types of exercise, there are exercises over there to do. Anything you want to do and practice on. We good?
Mm-hmm.
All right. Okay, and again, to make sure you don't miss it, you go to 345 and you click on the watch and you log into GitHub, you click on watch. Any change, any new thing, it's posted here, automatically you're going to get an email from the GitHub saying that, from GitHub organization saying this was updated, or maybe there is a bug in assignment 2 and they fix it and you'll see exactly what happened. So that's what you do. All right.
Excuse me.
Yes.
So for the assignments, do we also need to use GitHub, or just we're gonna just submit it through like on the matrix?
Okay. I don't know how to answer that question. GitHub is not a must. Okay? GitHub is how a professional programmer approaches developing an application. You should live and breathe in your GitHub account for anything that you do. I don't want you to add anything into GitHub if you don't want to, but if you need my help, I only accept GitHub collaboration, which means you need help with anything, it should be in your GitHub. I'll pull your GitHub and I'll get the values. And these assignments have been repeated forever. Be extremely careful, okay, when you are submitting them. If you want to get a shortcut and get a copy of the assignment from someone, you're gonna get flagged immediately. So be careful, okay? Don't
Okay, thank you.
do it yourself and don't copy anybody else's assignment. Be extremely careful. That's all I'm saying. Okay. Yes.
Excuse me, what's the due date for the second assignment? Oh, I mean just like the command the party doesn't work for looking for that.
Okay. There is an option called -do to the submission command. You
Oh,
go
yeah,
on,
but
you go on
it
PuTTY,
doesn't work.
you go on PuTTY, you write the submission command, you write -do, it tells you what the thing is. For assignment 2, give me a second. Give me a second, please. I have to log into this PuTTY thingy, and for some reason it doesn't do it. Give me a second. Okay, finally. Okay, I'm in. So you go tilde farda.suleiman/submit, and it's 345 assign 2, right? That's what it is, I think. And then -do. How do you submit it, people? Assign, is it like that?
You just spelled submit wrong. So it's SUBMIT.
Oh. Thank you. Submit, assign to, there we go. So that's how it shows. And when assign 3 comes up, that's assignment 3 and so on and so forth, okay? And if you need
Oh, yes, thank you.
And if you need extension, you let me know the way I told you, please, okay? I need to know number of days after the original due date. So you need to tell me I need 12 days to be added to the original due date. That's what I need to know, okay? Because that's how the extensions work. You cannot tell me I want extension till Wednesday. Then I have to look at the date for Wednesday, and I don't know what is your due date. And anyways, please follow the instructions. Okay. In 5 minutes, we're gonna hear another person. When is it due? Okay. We're good. Let's 5 minutes break and then come back, okay? And we're gonna continue with the overall things about functions. And we have till 11:35, correct? 11:35, right? It's 58, so yeah, so 11:05 we'd start, so we have 30 minutes to go through stuff. Thank you. Meanwhile, so first name? Tang?
Yeah.
All right. Let's, first name? First name? C-H? Ying? Yeah. All right. And first name starts with? First?
I need to know.
Nah, and Eo, never, yeah. Your last name in my language means sunny. Lots of sunshine. Okay. And, sir, next person. Oh. First name? Wesley? All right. My lady, first name? R. And CJ. First two characters, please.
J-I.
J-I. Oh. Gina, okay. So it's Gina or Gina?
It's Gina.
Gina, okay. One of the tricky ones that you never pronounce properly, eh? Huh?
Ariana.
Ariana. And Sahan. My friend? A-L? A-D? Adebayo, yeah. My lady? R? Okay. Rosario. All right, thank you. Yeah, I just took attendance in class, so those people who are at home, I'm gonna open up the attendance in, like right before we start, and you have 1 minute to submit your attendance, so be aware. I'm gonna let you know that attendance is open now, and then you start doing it, and then we're done. This is section B, yes. One more minute and we'll start. Put this one over here. And where do we go? Okay, so functions in C++11, they introduce auto, the auto that we have that we can actually create a variable for any type that we want. They added auto for functions, so you can actually have a return type for auto, and it automatically sets the auto the return value of the function. And also we have trailing return types, which essentially sets the return type after the signature of the function, therefore give a chance to the compiler to kind of figure out what the outcome of the
Professor,
yes.
what's the code to the attendance?
I'll let you know. I'll let you know in like, because some people may not came back from the break. In like 10, 15 minutes, I'll let you know.
Okay.
Okay, all right. So as you see in here, the ticket of mine has an enumerated class ticket type inside. So the set that I have over here is essentially setting the ticket type, and get has an auto with a trailing type coming back. See, so it says auto get and then ticket type. So it essentially means that's what the return type of the ticket is. And you can do that for any function you have. So this essentially could be auto, and say the return type of this one is OStream reference. Okay, it's the same thing, no difference. You don't have to do it. You do it when you need it, and I'll tell you when. Okay, so I could have over here auto int retained. Don't do it when you don't need it. Just regular functions will do. We'll come to it and you'll understand. So this is essentially like what it's good for is that you can have something like auto ticket type is set to a.get. Okay, and doing something like this, you essentially, from the return type of the get, you will actually set the ticket type to whatever it's going to be. So you don't have to write this long ticket scope resolution ticket type yada yada to get anything out of it. So that's that. So this is the auto and trailing. So auto and trailing type for functions. You need to know that. Now to explain where really auto becomes needed and why do we need it, look at this code. Okay, so I'm creating a template that adds two different types. So I'm saying constant T reference T and constant U. So I have two different types over here. So this could be add for int and a long, character and a short, integer and a double, but the return type depends on what is the value over here. If it's double and an integer, it's double. If it's integer and a character, it's int. If it's long and an int, it's long. Yes.
What is default type?
That I'm gonna go to that. I'm leading to that. Because you don't know what is the type, you call dec type over here. So this essentially says extract the result of the type this operation, and auto becomes that. Now I can actually say add I and j, and the return type will be an int. And if I do like that, so essentially it sets the return, and that was impossible. If you wanted to create a template, what could you do? Could you write int? No, you can't, because you don't know what the outcome is. You want the outcome to be the type of this. Auto is for that with declare type. So declare type finds out what is the type. Auto sets that one to the type that it's supposed to be. For this, it doesn't look kind of logical, because it would say, oh, I could guess what the output is. But when it comes to a standard template library, sometimes templates are so complicated and complex that it literally becomes impossible to walk through the logic to see what the outcome is. And because of that, then you use auto to literally generate the type that you want. So if in here I had auto result set to add I and x, result would be a double, because the automatic declaration type over there is a double and an integer, and therefore it's a double. Got it? Why auto is really needed. We talked about internal linkage for variables. We said if you want a variable not to be global and only have a file scope, you make it static int whatever, static global variable at the top. When you write static, then they cannot extern it. It becomes file scope. You prevent it to be global. You can do the exact same thing for functions. So you can literally have something like, oh, not like that. Give me a second. Yeah, there we go. Now I have two displays over here. One is in function linkage a.cpp, the other one linkage b.cpp. Two different modules. In here, I'm saying static void display, and in here, I'm saying static void display. Therefore, the display function in this module cannot have a header file with a display prototype for it. Or if there is a display prototype in any header file, it cannot tie itself to this display. Display is only for this module and cannot be external. So if you want to have a function to be used in one file and not by mistake to be used by someone else if they have a prototype similar to this, you make it static. Therefore, if there's a display that is not static somewhere else, that will be picked up. Okay? So it makes it essentially internally linked. So there is this game called Hanoi Towers. So Hanoi Towers is essentially a game that has a very simple type of rule that is, give me a second. Oh. Sorry. Trying to bring it up. Copy. And hopefully paste. There we go. Done. Okay, so first let's, I'm going to ask you about, I want you to picture one thing. When you look at a tree, what is the specification of a tree? It's a trunk, branches, and leaves at the end, right? Now let's break one of those branches and stick it to the ground. When you look at that branch is still a smaller tree with all the definitions. It has smaller branches and it has leaves, right? You break one of the branches of that one and put it, then you have a smaller tree. So essentially, a tree is defined by its own definition. What is a tree? Tree is a bunch of small trees attached to trunks with leaves at the end. Doesn't make sense, does it? But it is true. These are called fractal shapes. All fractal shapes are made of their own. And when you think about it, everything's fractal in the world, but I'm not going to go like that. So just think about it. And Hanoi Towers is a game that is almost that. It's not almost that, it's exactly that. So essentially, what is a Hanoi Tower? Hanoi Tower's rule is this. It says you are allowed to move one ring at the time from pole to pole. So I have A, B, C. I have 3 poles. The objection is to move all the rings from one pole to another. The rule is that you can only allow to move one ring at a time, and you can only put the smaller ring on a bigger one, not anything. So these are the only 2 rules. So I can only move this one and the next one. So, but when you think about it, Hanoi Tower is built up of Hanoi Tower over a big ring. This Hanoi Tower, that is 4 rings, is built up of Hanoi Tower with 3 rings over a 4th one, right? So the solution for this would be, if you want to move from A to B, use the rules for Hanoi Towers to move the 3 to C. So the 3 comes over here. Then move that single one over there. Then use the Hanoi Tower rules to put the 3 over that. and the problem is solved, right? So essentially, this is what I want to do. I want to move everything to that, move one single thing, and bring everything back over here. And you got to tell me, hey, you didn't solve any problem. You didn't tell me how to do the 3. And I would say 3 is a Hanoi tower of 2 over 1. Just move the 2, and then same thing. Then you say, you didn't fix the problem for me. I would say Hanoi towers of 2 is a Hanoi tower of 1 over a big one. Can you move a single one? You would say yes. So if you go backwards now, everything's going to get fixed. So essentially, when you go backwards, this is what's going to happen. First you move, then you do, and you go. See, that was a Hanoi tower of 2 that was fixed. Now it comes over here, that's the Hanoi tower of 3. Now it goes over here, that's the Hanoi tower of 2 and 3. So you put everything back in. Now, so, does it make sense? Like this? Okay. Let's see where I want to go with this. So, give me a second. So what I want to say is, I want to write a function that solves that game for me. Tells me how to do it. So I don't have to do it myself. So think about it. I want to write a function called Hanoi that has n rings. 10, 5, 2, 3, whatever it is. Okay? So I want to move everything from pole A to the last one, C, using the middle one, B. Correct? That's what I want to do. That's what I want to do with my Hanoi tower. So if I want to do that, let's actually lose what I said. So a Hanoi tower of n is actually just a Hanoi tower of n minus 1 and 1 ring, right? So I'm going to say, first of all, if n is not equal to 0, I have to do anything. Other than that, problem is solved. If I have no ring, problem is solved, right? So what I do, I'm going to say, to solve this problem, I'll call the Hanoi tower, and I'm going to say it's n minus 1, okay? First, I have to move from A to the last one, right? That is B using C. So first I have to use these 3 to the last one. Now that I have done this, I only have 1 ring left at the end. How do I solve that problem? I'm going to say move ring number n to from A to C, right? So I moved everything from A to B. All I need to do is put that one to C, right? So I moved that one. That's done. Now I have to bring everything back from that one to the original. So put it on the middle one. So I have to say, get that n minus 1 that I had on B, move it to C using A. Done. Problem solved. This function will actually solve the problem for you. Looks crazy, right? How am I calling a function inside the function itself? So in here, all I need to say, Hanoi 4 from A to C using B. And I run the program, and what I get is follow those instructions, and you will do it. It will do it for you. Literally, you have to put 1 from A to B, ring 2 to A to C, ring 1 from B to ring 3, and you do all those things, and it actually does it for you. It literally goes through every single thing. And just for you to see how long it takes if it's 10 of them, wow, the computers are getting much faster. I remember that like 15 years ago when I did this, it took a long time to go through it. But if I don't know, it goes up exponentially, so if it's 20 of them, it's going to take a little bit longer, I presume. Okay, so I don't know how long it's going to take, probably till the end of your lifetime. I don't know. Anyways, so that's it. But this is essentially the solution for it. Let's stop this. Okay. All right. So that's essentially how Hanoi towers are. And how this thing is done is called recursive. This is the magic of a theorem in math called mathematical induction. So what happens is that it says that if you satisfy few things in a problem, the problem will solve itself. Which means the very first thing that you need to do, you should assume that the problem for the rest is already solved. Okay? Then you stop when there's nothing to solve. And you have to prove that if you assume the rest is solved, you have the solution for the last one. And then everything falls on, like dominoes, it falls on itself. This solves the last one. The last thing that I have, this solves the last problem. When you look logically, that's exactly what it is. If I did it at the beginning as you saw, it proves that it's good. And it stops when nothing is there, and problem is solved. So it's done. So you can do this. This is like the one with Hanoi, but there are simpler things too. K, J, K, L. This is called recursion, that you can call a function in itself. This is called recursion. And there you go. This is a very simpler example with maths factorial. So factorial essentially means factorial of a number is a number multiplied to the rest of the stuff before it, right? So a factorial of x is always factorial of x minus 1 multiplied by x, right? And it stops when x reaches to 2 because 2 multiplied by 1 is 2. So I fix the problem for the very first element, and I prove that the problem is solved assuming that factorial x minus 1 is done, and therefore it does. And you don't need to do stuff like this. It's when you take the DSA subject, that's data structures, it's all this. But you need to get introduced to it, and this is what we do. So they did this. They had this research I think in a high school. They were teaching computer science. They did not teach any loops. They just taught them recursion from the beginning. And those people could not think in repetitions anymore. They would think of every problem they had as a problem that can be solved by itself, and therefore no loops. Factorials are extremely expensive. Why they're expensive? Because each function is calling itself, that is calling itself. So each function call is a separate call in memory. and all the results are pushed in a stack. It uses humongous amount of memory, but it's easier to implement. That's the difference. If your brain can work recursively, its solutions are much easier and shorter to do. Okay, so for the people at home, the code for the code for the attendance is 490603. I repeat, 490603. Okay, so that's that. And we have 5 more minutes, so I'm going to go through those. 490603. Do your attendance, 490603. And you need 1 minute to do that, so I'm going to wait for 1 minute, and we have 5 more minutes to go. Don't pack your stuff.
How do I submit my attendance?
Pardon me?
How do I submit my attendance?
I asked for your name, didn't I?
What's that code?
I did it manually. It's for people at home. Okay. Okay. Those who are at the computer. So they have 1 minute to do this. And that's that. So now, all right. Okay, so let's continue. All recursive stuff have a linear solution. All recursive stuff have linear solution. So all the factorial stuff that you're doing, you can do it linear. There is no problem. So, but that's much simpler. Like when you look at it, like even Hanoi, like it's much more difficult to do it in a linear way, but yeah, just keep that in mind. We talked about function pointers. We talked about array of pointers. We talked about functors. Now, we are going to talk about one more thing, and we'll be done for today. So, as we go through functions, we find the need for saving time writing small functions. Like remember the thing that I did with function to pointer to functions? I had 2 functions created over there, return the Boolean, and for every single thing I had to write a one-liner function just to do a comparison and return something. So we have a way to fix that. So what you can do, you can create a local function inside another function, small little tiny function, and hold it in a variable and call it, and when your function is over, that function will be gone. It's like a temporary function that you want to use quickly. How you do it, you create using auto. So you write auto over here. Say, I want to write a function that prints hello. So I'm going to call that hello, and I'm going to say equal to. This is called the capture clause. You do that, it means what you are creating is that tiny little function. Now that function doesn't receive anything, so that's its argument list, and its body is return hello there. So this hello is now a function that returns hello. Or, and you can call it, you can actually write over here hello and say see out hello. See out hello. So if I run this, it's going to print hello. It looks unnecessary, but you'll see it comes in handy, okay? Or if I want to say say auto, double it will be a function that receives an integer and doubles the value. Return n multiply by 2 and returns it. And so in here I can say cout, double it, 500. So now it's going to show 1,000 over there. Okay? What these tiny little functions are good for. Why? So these are actually called lambda expressions. Lambda expression. Lambda expression means tiny little function. Okay? So I'm going to call this over here n lambda intro. Now we'll go back to what we've written over here for the C way of passing pointer to functions and stuff like that. You see this? Control A, copy. You see that little thing? Like, what is this function? Why do I have to write a function like that? You see this is adult thingy over here? This is what I'm going to do. I'm going to say, instead of calling as adult, I'm going to say, this is a little function that receives an integer. And the body of the function is to return num greater than 18 and num, or greater than is equal to 18 and num less than or equal to 65. Semicolon, close it and close it. So I don't need this anymore. You see that? So I don't need to write the whole function. I'm just going to write the little cutesy function and we'll be done with it. Functions, like, and it's not difficult. Just take a look. I'm just going to copy this. You see this bool thingy that I copied? I'm going to go remove it completely, put it instead of this one, Control V, okay, and just remove these and put this instead. Remove these and put these instead. Done. So essentially, I'm saying get int, this is the function I'm passing to it. You can write it in multiple lines, but if it's small, it's easier to write it in one line. So this is your function that is being passed to it, and it's done. Lambda expressions, okay? And that's that. So the next day you're coming in, I'm going to show you what happens in future when we are talking about lambda expressions. Yes?
Do you also have to auto the age and the number of students?
Auto?
Yeah.
No, we don't need to because it's receiving a it's receiving. In here, you're mentioning what it's receiving.
Oh.
Because you're mentioning it knows what it is. You don't need to auto. We good? We good? Okay, have a good day. If you have a question, let me first close down my stuff, and then I can answer all the questions you want outside. September 29th, MBB. Thank you.